Friends, basically there are two methods to calculate the torque. One is graphical method, that is Kleins construction method, and other is analytic method. So here in this video lecture we only deals with Kleins method to calculate the inertia forces and torque. Now we will solve a problem on Kleins acceleration diagram. So this is our question. The following data refers to a horizontal reciprocating engine. Parameters are given as diameter of piston is 75 mm, stroke length 300 mm, length of connecting rod 400 mm, and mass of reciprocating parts 125 kg, mass of connecting rod 100 kg, engine speed 750 rpm, CG of connecting rod from crank pin 160 mm, and radius of gyration of the connecting rod about an axis through CG is 120 mm. CG is nothing but center of gravity. So question here is we have to determine the magnitude and direction of torque exerted on the crankshaft when the crank is turned through 30 degree from the inner dead center using Kleins construction method. So these are the given data. Diameter of piston 75 mm, converted into, first of all convert all the parameters in meter from millimeter. Length is 300 mm, so R is equal to L by 2, that is 300 by 2. It will come out to be 150 mm, that is 0.15 meter. And length of connecting rod 400 mm, that is a small L. It will come out to be 0.4 meter. Mass of reciprocating and mass of connecting rod as 125 kg and 100 kg respectively. In engine speed is 750 rpm. So first of all we want to calculate omega value, that is angular velocity value from engine speed. The formula for that is 2 pi into n by 60. 2 pi into n value we know 750 by 60. It will come out to be 78.53 radian per second. Now we know center of gravity value as 160 mm. We know radius of gyration value as 120 mm. Now to construct Kleins acceleration diagram we have to take some suitable scale for that. Now here I am taking 100 mm as 3 cm. So the new length for construction will become L dash as 4.5 cm as it is 150 mm. So for 100 it is 3 cm and for rest remaining 50 it will 1.5. So it will sum out to be L dash as 4.5 cm. And a small L we know 400 mm means 400 3 cm means for 400 it will come out to be 3 into 4, that is 12 cm. And similarly for GC dash it is 160 mm means it will come out to be 4.8 cm and kg it will come out to be 3.6 cm. Name it as this point as P and this point as O. Now from O construct a line segment which is inclined at 30 degree to the line segment OP. Yes, we have to draw 30 degree because it is given in question, and the length should be, here we can see it is L dash is 4.5 cm, that is the length of the crank, so it should be 4.5 cm. Yes, it will come here. Mark it as C. Now from C measure a distance is equal to 12 cm, which is nothing but L dash, that is the length of the connecting rod. It is given L dash is 12 cm. So from C mark 12 cm and cut it on OP. Now join these two points. Again, from O, draw a perpendicular and produced PC. Extend PC. The point where it intersects the perpendicular, name it as M. Now, taking CM as radius, draw a circle. Again, taking PC as diameter, draw another circle. So the radius of PC will come at 6 cm. This is because the length of PC is 12 cm. Now, the point where these two circle meets, name it, join these 2 points and name it as K and L. And the points where this line cuts PC, name it as Q, and where it cuts OP, name it as N. Now join N to C. Now it is given in the question that center of gravity from crank pin is given. This is as which is nothing but 4.8 cm. So from C point we will measure 4.8 cm. Draw a perpendicular, name it as G. Draw a perpendicular from G on PM. The length of this G perpendicular will be equal to the length of radius of gyration, which is kg is 3.6 cm. So it will come somewhat here, name it as Z. Now join P to Z. Again from PZ, draw another perpendicular on PZ which should intersect to PC. Name it as capital D. Now from G and D point, draw a parallel line to OP which should intersect on NC. From D point, draw a parallel line to OP. It will come somewhat this way. Yes, and it should have intersect on NC. Name it as small d and this one as a small g. Join these 2 points to the O point. Okay. Now what we have to do, from D draw another line which is parallel to OD and which should intersect on OP. It is somewhat like this. Yes, the point where it meets OP, name it as S. Now from S draw another line which should be parallel to OG. From S draw another line which should be parallel to OG. It will come somewhat this way. Now extend OC. Again, what we have to do, from P draw another perpendicular line which should intersect on OC produced. Name it as I. Now from S produced draw a perpendicular line on S produced which should meet the point I. It should be perpendicular in such a way that it should meet the point I. Join this. Name it as capital X. Now what we have to do, from G draw a perpendicular line on OP. Now from I draw a perpendicular line on G produced. It will come somewhat like this way. Name it as Y. And this is the weight of reciprocating part. Name it as WC. This is Fn force, inertia force. This is Fi, and this is inertia force due to connecting rod, Fc. This is inertia force due to reciprocating parts, Fr. Now we have to find the tangential force acting on the crank, which is OC. So the tangential force acting on the crank in this way, it should be perpendicular . Name it as Ft. Now I will mark all these lines which we have to calculate. First of all, mark OG. Then IY. Now we have drawn the Lenz's acceleration diagram OCQN. From figure it is OCQN. So this is our required Lenz's acceleration diagram. But in this problem we have to calculate torque. So we will focus on calculating the inertia forces acting upon by the stroke and due to the connecting rod. So we will mainly focus on calculating the inertia forces. Now by measurement, our length NO. From figure we will see this is our ON length. So by measurement it comes out to be 4.5 centimeter. So but initially we have taken some suitable scale. So NO is coming out to be 4.5, that is 100 mm is 3 centimeter we have taken. So 1 centimeter is 100 by 3 mm. So for 4.5 centimeter, this we have just now measured. For 4.5 centimeter, it will come out to be 100 by 3 into 4.5, that is 150 mm. So in meter it is 0.15 meter. Similarly, we will measure GO length. This length GO. Similarly, it will come out to be 4.5 centimeter. Then using suitable scale, convert it into mm and then into meter. And similarly IC, this is our IC length, this is our IP length, this is our IX length, this is our IY length, this is GO and this is ON. So IC is 13.7 centimeter, multiply it with 33.3, we will get 456.2 mm. Now convert it into meter, 0.456 meter. Now come on to the calculation of inertia forces. We know that inertia force of reciprocating parts is Fi is mass of reciprocating parts into omega square into NO. We know Mr as given in problem as 125 kg. We know omega we have calculated by the help of engine speed, which is 78.53 square into we know the length NO 0.15. So it will come out to be this value 115630.51 Newton. And inertia force of connecting rod Fc is equal to mc into omega square into GO. As you know, mass of connecting rod as 100 kg into omega we know 78.53 and we know the value of GO 0.15 meter. We will get 92504.4 Newton as the inertia force due to connecting rod. Now force acting perpendicular to the crank OC. From figure we see here clearly Ft is the force acting perpendicular to the crank OC. OC is our crank and Cp is our connecting rod. So the force acting perpendicular to OC is Ft. Now what we have to do? We have to take moments about point I. This is our point I. We have to take moments about this point. So Ft into IC. Ft. This is our Ft and this is our length IC. So Ft into IC is equivalent to Fi into IP. This is our Fi into this length IP, as torque is nothing but force into perpendicular distance. So we are mainly focusing on the force acting on that point. From that force we need a perpendicular distance to the point where we need to be calculate the force, plus Wc into Iy. Wc weight acting due to this connecting rod, which is nothing but 100 kg and the distance between them is Iy. So Wc into Iy plus Fc into Ic. Fc is here. This is our Fc force, inertia force due to connecting rod into IC. This is our length IC. So multiply it, then substitute all the value. We know the value of IC, we have just calculated. We know the value of IP, FI, WC. Here one precaution is taken, that we know the mass of the connecting rod. So to calculate the weight, we need to multiply the mass into 9.8, that is G value, into I value we know, FC value we know, and IC value we also know. So substitute all these value, then finally we will get FT is equal to 171603.0 Newton. Now as you know, this is our tensile force. So as you know, torque exerted on the crankshaft is nothing but Ft into R. R is our stroke length, that is OC. This is nothing but 300 mm. So as we have calculated, it comes out to be 0.015 meter into Ft. Substitute this value 171603 into 0.15. We will get the torque acting on the crankshaft as 25740.46 Newton meter, that is 25,740.46 Newton meter as our torque exerted on crankshaft.